Okay, today, like every day, there will always be a question waiting for you on the Socrative app, so you are expected to get that answered and whatever before you get in here. So we'll go ahead and check your answer to see how you did. And it looks like a few of you still need help. We have 4.4 times 10 to the 22nd over 6.6 times 10 to the negative 33rd. So if we come back here, check out the way that we would enter this into our calculators. We should enter this in like this as 4.4, and then which button do we hit? EE or EXP, depending upon your model calculator. Some of you might have a times 10 to the X button. Then you would put in 22, and then what's next?
Divided by.
Divided by. And then what's next?
6.6.
6.6 followed by?
Double E.
EE, followed by the negative or your sign changing button, and then 33, and then enter or equals depending upon your model calculator. And this is how you go about entering that in, and you should wind up with an answer of 6.7 times 10 to the 54th. Any questions on this particular one? Is Brooke here today? Brooke? Not here. Yes, sir.
I was going to mention that we should also probably enter into parentheses just so we don't get any mixed up calculations.
What's that?
We should probably also enter into parentheses around 4.48 22nd and 6.6 times 10 to the negative 34 just so we don't get any mixed up calculations probably.
There's no need to do that. If we use the scientific notation feature, there's no need for parentheses on this. And so that's the importance of why we learn what the EE button stands for.
Right.
Is because the EE tells the calculator that you're dealing with scientific notation. And so your calculator knows how to do scientific notation, and that's why we learned how to do it the way we did. If you're dealing with the parentheses, people that use the wrong button use the anti-log key. They're the ones that have to nest parentheses and whatever else. And so, again, if you do it like this, there's no need to worry about parentheses.
Oh, okay.
Anybody else? All right, a few announcements. Again, only for the first 2 weeks, remind you of your responsibilities in here. Starting next Tuesday, a week from today, we'll not be going through this before class every day. So your email is due this Thursday, so you have 2 more days to get that email in. Then your syllabus quiz is due on Friday on D2L. The first Mastering Chemistry homework quiz is due next Monday. And there's an extra credit practice problem that's due on Mastering Chemistry tomorrow night and another set on Monday. Anybody have any questions on the syllabus? How many had a great extra day off? Good. All right. Last week in lab, you were supposed to attend. If you did not attend, you need to have some required safety training that takes place before you can participate in lab activities. Now, I'm not teaching any of the lab sections this semester, but if you missed lab, you will want to contact your lab professor as soon as possible. In this class, it is either Beefus or Lutz, is that correct? Okay, so make sure that you contact your professor, lab professor, on the safety training if you missed that. Also remember that before you come to lab this week, you do need to complete a pre-lab quiz. That pre-lab quiz should be already waiting for you. Am I lying? Is it true? Has anybody checked? It's waiting for you? Okay, so make sure that you complete that. If you do not complete it with a score of 2 out of 3, you'll probably be met at the door and asked to turn around. And then, again, every day in class, you're going to sign in into the Socrative app, go to the Chem room, and sign in with your chemical symbol in place of your name. Any questions on the routine? All right. Well, let's get to it then. Last week we looked at significant figures, and there's a reason why we look at significant figures, and it has to do with how we make measurements. And start with this example here, and I don't know if I showed you this last week, but if you're wondering what this is, there's a camera up in the ceiling up there that we use to demo things. And so what I have here is an index card, and with that index card I have gone through here and made some measurements of length and width, and upon doing so came up with these measurements right here: 15.23 centimeters and 10.21 centimeters. Now before we go ahead and do any calculations with these, what do we call this last digit in each of these measurements? Go ahead.
It's the uncertain digit.
It's the uncertain digit, exactly. So in this case, even though we've not shown it, we're assuming that the uncertainty is plus or minus 1 in the last digit, so we'd say that the uncertainty in this is plus or minus 0.01, and the label we give is?
Centimeters.
Centimeters. Okay, so that's the uncertainty we're giving, and remember that when we make a measurement with the measuring device, we always go one digit beyond the smallest division. So we're showing here, if we look at the length of this measurement, and it's kind of hard for me to do this without my glasses or whatever, but if we were to look at this and I laid it out on here, notice that each of these markings now go out to the nearest tenth of a centimeter, so that uncertain digit is one digit beyond the smallest divisions that are on this measuring device. So with these measurements, go ahead and calculate the area. Go ahead and calculate the area. And again, those measurements were 15.23 centimeters and 10.21 centimeters. And so now if we run these through our calculators, I'm going to just write down all of the digits on here. What did we come up with? Go ahead, where are you at? 155.4983. And what label would we give here?
Centimeters squared.
Centimeters squared, exactly. So now remember that these digits on here are the uncertain digit. So if I repeated the measurements, maybe the next time I come up with 15.24 centimeters by 10.22 centimeters. And maybe I repeat it again and come up with 15.22 centimeters by 10.20 centimeters. And maybe I do it a fourth time and come up with 15.24 centimeters by 10.21 centimeters. So for each one of these now, we're going to go ahead and calculate an area. So I'll take 15.24, multiply by 10.22. Okay, we'll try it again. 15.24 times 10.22. Come up with 155.7528. And you can run these through your calculators and just verify mine. So 15.22 times 10.20 and come up with 155.244 square centimeters. And 15.24 times 10.21 is 155.6004 square centimeters. And so remember, with each one of these length and width measurements, which digit is the uncertain digit in each one of these?
The 100th.
The 100th place. So we go down, and this here, I'm just emphasizing, is the uncertain digit. Well, then what we do is we look at our area over here. We want to figure out which digit is the uncertain digit. And the reason why that uncertain digit is important is because when we give our measurements, let's see here where we have this defined, there we go. We define the significant figures as all of the certain digits in a measurement plus one digit that is uncertain. So it's all of the certain digits in the measurement plus one digit that is uncertain. So we come through here and ask ourselves, does it appear that the hundreds place is a certain digit?
Yeah.
Yes, it is. How about the tens place? Is that certain?
Yeah.
Is the ones place certain?
Not necessarily.
Does it look certain?
Yeah.
And how does it look certain?
Because they're all the exact same.
All the same. Does the tenths place appear certain?
No.
No, and this is where we start to see some variation. So if we go through here, I'm just going to underline this. This digit here now is representing the uncertain digit. So now, if we want to give the answer with the correct number of significant figures, we give that answer, so the answer has only one uncertain digit, which means we're drawing the first one off, the 155.5. We round the second one off to 155.8. We round the next one off to 155.2, and then the last one to 155.6. And this is the correct way to round these answers. Okay, now this will bug some of you because you've been through your math classes and you've learned in math, oh, well, since these are out to the tenths, these, not out to the tenths, these are out to the hundreds, these are out to the hundreds, that must mean we round these to the hundreds. Well, if we're looking at the precision of our measurements, or the reproducibility of it, this is only reproducible out to the tenths place, because that's where the uncertainty lies. We cannot justify going any further. So what this does for us then is it gives us a rule, and that rule for rounding looks something like this. We say that when we multiply and divide, your answer should be rounded. So again, for multiplication and division, your answer should be rounded. So it contains the same number of significant figures as the measurement having the fewest significant figures. So again, if I were to read this all out, your answer should be rounded so it contains the same number of significant figures as the measurement having the fewest significant figures. And I'll come back to this page in just a moment. So that means if we go back to our values here, and we ask ourselves, how many significant figures does this measurement have? 4. So these all have 4. How many do these all have? 4. So if we have a length that has 4 significant figures and a width that has 4 significant figures, the fewest of 4 and 4 is 4, which means our answer should have 4 significant figures. And so that's why we round these off to contain 4 significant figures. So again, what you do is you evaluate the measurement that has the fewest significant figures, and you round your answer off so it has the same number of significant figures as the measurement having the fewest significant figures. Well, now, of course, we're not going to be doing just multiplication and division. Sometime we're going to be adding and subtracting. So we'll see here now if I can get this to work. We'll try this. We're going to copy this, and we are going to paste this. There we go. And now I am going to come back here and change this definition to be for addition and subtraction. Now I change this to addition and subtraction. I need to change 2 words in here. Which words am I going to change? Well, this is where it goes back to probably what you're more familiar with. I'm going to get rid of significant figures and replace it with decimal places. And we'll get rid of the significant figures here and we'll replace it with the word decimal places. See, now this is when you wish you had a tablet PC. Just copy and paste. So again, multiplication and division we do in terms of significant figures. Addition and subtraction we do it in terms of decimal places. And again, the rule with decimal places is the one with which you're probably more familiar. So if we were to do an example that has addition, let's say we had something like this. We have 385.17 meters. We have 6.2 meters. And we have 45.76 meters. And we'd like to sum these all together. Now if we were to sum these together, looks like we get a 3, and you can run this through your calculator if you want. You don't need to do it the long way. So this would be a 3. Looks like this is going to be a 1. This will be a 7. This will be a 3. And this will be a 4. So we wind up with 437.13 meters. So now this is not properly rounded yet, or maybe it is, but let's just see. Now let's talk about this first one. Which digit is the uncertain digit in the top measurement? The 7 is. How about in the second measurement? The 2. And in the last measurement?
6.
The 6. Now, let's say we change the 7. Remember, if this is uncertain, we could repeat it again. This could be a 6 or it could be an 8 or something. This is uncertain. Which digit changes down here?
It's going to be the hundredths.
It's going to be out in the hundreds. So this is the uncertain one based on this measurement. If this is uncertain, let's say we repeat it and we come up with 6.3 or 6.1 the next time. Which digit changes in the answer here?
It would be the tenths.
The tenths place. And in this one here, the uncertain digit is the 6. So if we change this to 7 or 5, then the digit that changes down here is the
hundredths.
The hundredths place. So since this one winds up changing the tenth, this one has the fewest decimal places. And the number of decimal places in this one is 1. That means our answer here should have 1 decimal place. And we should round it off to 437.1 as the answer. And that's because this one right here is uncertain to the tenths place. And because it is uncertain to the tenths place, that means that the tenths place is going to be uncertain down here in these measurements. So that's why the rules for multiplication and division differ from each other. The rules for multiplication and division involve significant figures, and in addition and subtraction, they involve decimal places. So let's go ahead and practice here. I have a couple on your Socrative app, and you can get that loaded up. While you do that, let me tell you the 2 that you're going to be practicing. The 2 that you're going to be practicing are these 2 here. They are, first one is 162.110 grams over 8.35 milliliters. And then the second one that you'll be doing is going to be 275.71 kilograms minus 8.4 kilograms. So with each one of these, express them with either the correct number of significant figures or decimal places, and you will then find them coming up next on the Socrative app. Remember to talk with a neighbor before you commit yourself to an answer. Make sure you're in agreement. Part of this class is talking with your neighbors to ensure that we are all on the right page. All right, first one, what number goes in the blank?
1,000.
First number is 1,000. The second one is 0.001. Again, the way you want to think about it, think about the size of the units. If I offer you gold, do you want a kilogram of gold or do you want a gram of gold?
Kilogram.
You want a kilogram, right? So a kilogram is one that is
Bigger.
big. So the bigger unit's going to be associated with the smaller number. So then you know that this number is going to have to be bigger. If you know that kilo means 1,000, this is going to be 1,000 grams. Likewise, compare grams to kilograms. You know that the number associated with the kilogram has to be smaller. The kilo means 1,000, and this is going to be 1/1000th of a kilogram. Any questions on these examples? All right, that then takes us to dimensional analysis. Now this is something that, dimensional analysis is something that once we get going at it, this is one of those areas that sometimes challenges students. So I'm going to start with something very basic here. I'm going to have a multiplication problem of 3/4 times 4/7. And if we wanted to calculate this one and express our answer as a fraction, what would be one way to make this very quick? Go ahead.
You could find the common denominator.
You could find the common denominator, but that works with addition and subtraction.
Or just multiply through across the line.
And we simply multiply them, but how can we simplify this?
All cancel out the common numerator and common denominator.
Right, well, just cancel these out. And they don't simply disappear, they become 1 and 1. And so then the answer becomes here 3/7. Okay? So then if we went to something like this, feet times inches over feet times centimeters over inches, and we ask what are the units in the answer, what would those units in the answer be?
Inches?
Not inches.
Centimeters.
Centimeters. Why? What happens to feet?
Feet process out and then inches cancel out.
And what else cancels here? Inches. And again, they don't disappear. They become 1. So you take 1 times 1 times centimeters over 1. And this answer simply becomes centimeters. And that's what dimensional analysis is all about. That's what it says. We're going to be analyzing dimensions. So as long as you can remember that dimensional analysis is nothing more than multiplication of fractions, you have something in the numerator and denominator, and the sign between them is multiplication. They simply cancel out. So then if we had a measurement like this, let's say that we had 42 inches, and we wanted to convert this to feet. Now we're going to show this using dimensional analysis, even though I know some of us could very quickly go up here and say the quick way to do this is take 42 and
42.
divide by 12 and get your answer. But here's how we do it using dimensional analysis. So now let's say, pretend you don't know that conversion between inches and feet. We come back here and see that there are 12 inches in 1 foot. And we come back here then and we say, we could express it like this. We could either say that there's 1 foot over 12 inches, or we could say that there's 12 inches over 1 foot. Now only one of those two ways will allow us to cancel out units. Does this setup here allow us to cancel out units?
No.
No. So this one must not be right. The right way must be
1 foot over 12.
1 foot over 12 inches. When it's set up like this then, we have one unit over another, they cancel out. And the reason why we take 42 divided by 12 is that what enables us to cancel out units. So again, even though you may know a shorter way to do it, you say, I know this, you're not going to get the chance to practice dimensional analysis. So an easy example like this I like to show. So if we take 42 and divide it by 12, we wind up with
3.5.
3.5. And how many significant figures should be in that answer?
2.
2. And there should be 2 significant figures because this here has how many significant figures?
2.
And be careful now, this one here, this conversion has how many significant figures?
It's exact.
It's exact, which means that the number of significant figures is infinite. Okay, if there's an infinite number of significant figures, and this has 2, the fewest between 2 and infinite is 2, means that we should round our answer off to 2 significant figures. Let's do this one here. Let's go ahead and convert your weight, not my weight, but your weight, from pounds to kilograms. So I'm going to take 223 pounds, which was my weight this morning. And look at my old notes here, and I see it's 5 pounds heavier than last semester. So now we want to convert this from pounds over to kilograms. Now I suspect we don't know this one so well. So ahead of time we think, well, these English or SI units?
That's SI.
This is English.
English.
Kilograms, English or SI?
SI.
SI units. So we're going English to metric in what we're doing. So we come back and look at our English to metric conversions. This here's on our conversion sheet. And we find a conversion between pounds and kilograms, which is right here. We have 1 kilogram is 2.205 pounds. So now we want to take this conversion. Which unit do we want to put in the denominator?
We want to put pounds.
We want to put pounds in the denominator. So we look at that conversion. How many pounds are there? 2.205 pounds. In the numerator there is 1 kilogram. Right here, 1 kilogram. So we put that 1 kilogram up above. Again, we put the pounds on the bottom so the units cancel out. We take 223 and we divide it by 2.205. We wind up with 101.133. And then we ask ourselves, how many significant figures should be in that answer? 3. So I've drawn this off to be 101 kilograms. Now, if I did my weight from last year, my weight last year was 218, and it would have given me like 98 point, let's see, 15 divided by 2.205, 98.8662, etc. I want to round this off to 3 significant figures. I'd round it off to be 98.9 kilograms is the answer that I would have come up with this. And so, again, you want to consider significant figures because this measurement here has 3 significant figures. This conversion right here has 4 significant figures. The fewest of 3 and 4 is 3. And so we should round our answer off to 3 significant figures. And I always say if you're feeling kind of chunky in pounds, put it in kilograms, you're going to feel a little better about yourself. Okay. Instant weight loss. Okay, next up, let's do this one. Let's say we have 355 milliliters. We want to convert this to pints. Milliliters to pints. So before we convert milliliters to pints, SI units or English?
SI.
SI. English or SI? English. So we're going to be an English, I guess this is a metric to English conversion. So we come back here and we start looking for conversions that will take us from milliliters to pints. I don't see anything in here. And I don't see anything in here that's going to do it. So that means we're probably going to be doing more than one conversion. And this is where the advantage of using dimensional analysis comes into play. So one thing we could do is we could take the 355 milliliters Let's see, is there a conversion to quarts in here?
Well, I see a liter to quarts, which you could simply use if you want.
Okay. What's going to get us out of milliliters?
Or the ounces to, we could use ounces to cups and cups to pints.
Ounces to cups, so that would be a couple different strategies. So let's look at one strategy. Let's take our milliliters and let's first convert it to fluid ounces. I think that one is on there. Milliliters to fluid ounces. Here we go. Milliliters to fluid ounces is one that'll work. So I have 29.57 milliliters to 1 fluid ounce. So where did the milliliters go? Top or bottom?
Bottom.
On the bottom. And again, how many milliliters are there?
29.57.
29.57 milliliters, and that is the amount in 1 fluid ounce. And what will happen here now is that milliliters are going to cancel. If we stopped at this point, our answer is going to be in units of fluid ounces. We don't want fluid ounces, we're trying to get to pints. So then we come down here and we see that for every 1 cup, there's 8 fluid ounces. 1 cup, there's 8 fluid ounces. So where do we put the fluid ounces? On the bottom. So we put 8 fluid ounces on the bottom. The top we put in 1 cup. And fluid ounces are going to cancel out here. And then we go one more step, and we see that the conversion right below it tells us that for every 1 pint, we have 2 cups. 1 pint, there's 2 cups. Where does cups go? On the bottom. How many cups? 2 cups for every 1 pint. At this point, cups cancel out. The only unit that we're left with now is pints. If we're left with pints, we can go ahead and calculate this out. Remember how this works now. When we multiply these together, we multiply together all of the values that appear in the numerator. We divide by each value that appears in the denominator. So we take 355 divided by 29.57, divided by 8, and divided by 2. Because again, each one of these, if we consider them separately, this is the same as dividing by 8, this is the same as dividing by 2, this here is the same as dividing by 29.57. So if I put this in my calculator, and I'll show this to you here as I enter it in, I'm going to take 355 divided by 29.57 divided by 8 and divided by 2. When I do that, I come up with 0.7503, etc. And how many significant figures did we want in this?
3.
3 significant figures. So 3 significant figures, I'd round this off to
0.750.
0.750 pints. And that would be the answer. And the reason why I chose this particular one, if anybody has, I don't see it here, somebody has a can of soda there. Can of soda is 355 milliliters, and that's the same as 12 ounces. 12 ounces is 3/4 of a pint.
Oh,
Okay.
shoot.
So, any questions? Okay, let's go ahead and try this one then. Any track and field people in here? All right. Now, back in my days, we ran our distance around the track not as the 400, but as a... Ooh, good question. Let's see what it would be. Let's take the 400 meters. Convert this to yards. 400 meters and convert it to yards. And I believe this is your last question on the Socrative app for the day. It is. Track and field event is 400 meters. This distance is the same as blank yards. Give the answer with the correct number of significant figures. And before you enter in an answer, Don't just enter it in, compare it with one or two other people to confirm. So we got about 5 minutes left here. And while you're doing that, I'm going to show a different way to do this calculation above. So two different ways of arriving at the same answer. There could be multiple ways to arrive at your answer before you commit yourself. Compare your answer to the neighbor. We have about 5 minutes remaining here. We're not going to rush. It's the last problem for the day. Five, four, three, two, one. We should have come up with 437. You were asked to express this out to the correct number of significant figures. With the decimal point here, there's how many significant figures? 3. So if we come back here, this should have been 3.281 feet. This is at least one way to do it. And then your next conversion would have been on the top. Let's see, on the bottom would have been 3 feet to 1 yard. These would have canceled. You would have come up with 437. Of course, I didn't run the 437. I would have ran the
400.
Not the 400.
437.
The 440 is what we ran. So one distance around the track was 440. When we changed over to the metric, we had to shave a little bit of, we had to add a little bit on, shave a little bit off, I guess, what we had to do on the track. So that's it. We'll see you later.